Cool. So we're recording again. We're back. Yeah, so where were we when I last dropped off? We were about to start with queries, but just to go over it again, any questions about what we've currently covered? Because this is a brand new idea. And I would say after Python and JavaScript, SQL is essentially your third programming language. PostgreSQL is your third environment. You have the front end and the back end, but then databases is its own thing. So there's, this is sort of your third tool of your primary tools. So it's worth understanding it and asking the questions now if it feels confusing, though this is just an intro. Okay, well, if we feel good about it, we can keep messing with some of these queries. So SQL stands for, actually, what is the S? Can anyone tell me what does the S in SQL stand for? Sequential or standard or something?
Structure.
Structure. There we go. Yeah. So SQL stands for structured query language. And the core idea there is the Q, query. So SQL is a language, like a programming language, that allows you to interact with your database. So you don't really need to know how your database works. All you need to know is the commands that let you store and retrieve things from the database. So beyond creating or destroying a table, your main queries are going to be for tables that already exist. So select is probably the most common one. We would say, let's say we have this users table. We say select star from users, and that'll give us everything currently in the users table. But similarly, we could say, actually, I don't need everything from the user table, just want the email. So select email from users, and that gives us a list of just the emails for that user, or for all users. Similarly, we have insert. So it's not just insert, right? It's insert into or something. Yeah, insert into, and then the next thing would be my table, users, and then the next thing would be what I wanted to insert into there. So in this case, if we look, it has, if we look, our user has an ID, an email, and a password. So I could do that. I could say ID, email, is that what it's called? Yep, password. And then from there, I could say, I say values. Let me just make sure. The hardest part about SQL is remembering the specific syntax. So values, and I could say, well, actually, I want to give it an ID of 44. Let me try that. Wonder if it will let me. And then for email, a@b.c, it doesn't really care. It only cares that it's text. And then finally, the password ABCD. So let's see if this lets me do it. It looks like it did. And now, once again, I can select everything from my users, and I see that, okay, I actually do, I have that explicit ID of 44. But as mentioned before, I have those constraints, and that can change how insert into works. So for example, if I left out ID because it had a primary key constraint, it knows to actually just give me a new ID. So if I do this, and remember it has that unique constraint, so I'll do that. So that should work as well. You see, it just said, okay, well, what's the next ID? 3. And if it ever got up to, its next ID being 44, it would see it already has a 44, and it would never have 2 of the same primary key. But also there were those other constraints. So for example, if I try and repeat a password like an email like a@b.c, this should not work. And it's giving me the specific error. It said, you said this has a unique constraint around email, and we can't guarantee that based on what you did. And similarly, if I had null here, we had a constraint around that. So again, that doesn't work. It needs it needs that to have an actual value. And in reality, the truth is that the reason why that value thing matters or sorry, the reason why that not null constraint matters is because let's say I tried to do this. I say, okay, I want to insert into users. I messed that up a little. I want us to insert into users. I'll just take it for granted. You can make my ID for me. And then I want to, create a specific value. And that value is going to be a brand new unique value you've never seen before. And then because I didn't mention the password, I might think, oh, well, maybe this will work. It'll just give me a blank password, right? But this won't work because it'll say you have a, wait, what's its complaint? Null value. Yeah, null value and column password. It doesn't like that because it has a constraint around that. So it actually wants me to, even if I were to give it a blank password, I would have to do it like that, where I explicitly say it's not null. And now if I were to look at all my values again, I see it's in there. I have this unique, everything here is unique, and this is not null, rather it's an empty string. Okay, so that's, we've covered the basics of select and the basics of insert. So select, grab the data you want, insert, actually create new data. By the time we get up to backend stuff where we talk about RESTful APIs, you'll see there's a really nice one-to-one between the RESTful API approach and your database, because there's really these 4 key ideas. One of them is get. Select is get. It means grab things, don't change anything. Then 2 is insert, or what in RESTful terms, what is insert? I believe it's a push, right? Yeah. So so insert is the equivalent of push. What it means is this is brand new data. I'm giving you new data that I want to go into the database. Then there's update, which in RESTful terms we call put. So it's similar to insert, but instead of inserting a brand new row, you're saying grab an existing row and update some values of that existing row. So it's sort of like a combination of select and insert. Select, you get specific rows. Insert, you create a new row. Update, you grab an existing row by its ID, and then you change whatever you want for that row. And then finally, there's delete, which deletes an entire row. So let's see us do some of that. It's good to always know, okay, what is in my database? And then let's say I wanted to update something. Well, first I'd want to actually look at the syntax, because I often don't have it memorized. So if I were to look for update, look here, and it's update a table name, set the specific column to a specific value, and then you could have conditions if you want. So let's try that. And notice that in SQL, we generally don't care about white space as long as it ends in the semicolon. So we're going to update users, right? I need to regularly look back and forth at this, so I'm going to put this right here. Update users and then set the specific things. So I'll say oops, that's not going to work now. I want to update users. And what does it mean to update a user? Well, I want to set some values. And how do I set the values? Well, let's say I care about my 4th element or something, or I care about the thing with the ID of 44. So I'll say, how about set, I'll just set one thing, and that thing will be the email. So I'll say set email equal to, and what should the new email be? It'll be a@hotmail.com. Okay. And then I'll say set, and then what comes after that? Well, I could set more than one thing, but now I want to add a condition. So I believe if I just let this run, I'm not sure how it would work without a where statement. Maybe it doesn't work without a where statement, because what I'm saying is basically update users. Which users? Well, I guess all of them, and set their email to this specific thing. But instead, I'm going to add a condition, which we do that with the where statement. So I'm going to say where, I'm And I believe what I would want to say here is where users.id is equal to 44. And is that a good where statement? Yeah, that looks like that should be a good where statement. So let me end that with a semicolon and hit enter. And it didn't like it. It said that column doesn't exist. Where do you think I went wrong? Column at Hotmail does not exist. Did I do these in the wrong order or something? Seems like based on what they said, I say column equals value. Not sure exactly where I went wrong. Maybe it was lacking the comma or something. I don't know. This looks like exactly what I just did. I'm not sure why that's not working. Yep.
It might be single quotes.
Ah, right. Yeah. So that is a good point that a lot of times things like, if you're used to Python, JavaScript, you think like, okay, single quotes, double quotes, interchangeable. But often in a given language, especially something as old as SQL, it's not. You have to be very explicit. So that did work now. And if I look at all of my users, I'll see that for user 44, we didn't, for user 44, we grabbed 44, we didn't add anything new to the table, but we updated what its email was. And how it's printing it now, it's printing it at the end, because I guess it's the most recent thing that was added. But the order doesn't really matter. What matters is that, we didn't create a brand new element. We instead updated an existing element. And finally, we could do the same with delete, where, just making sure I know my delete syntax. There's delete. And you delete from table where condition. Okay, so kind of the same thing. I'll say delete from, again, that right? Yeah, delete from users. It could all be on one line where, I'll say where, it doesn't have to be ID. I could say where email is equal to a@hotmail.com. So it'll just look for the first thing with an email like that if there wasn't a unique constraint. And let's see what happens. It's saying column.
Double quotes again.
Double quotes again.
Oh, yeah, I got to get used to that. Okay, you see, I'm not used to my SQL. Okay, I do that, and it says it deleted it, and we can check, and indeed, it's not there anymore. So that's your basic select, insert, update, delete. And this, if this is Postgres's official site, or I don't know, PostgreSQL tutorial is working well enough for me, but basically, you wouldn't be expected to know all of the commands in SQL or their syntax, like, how it's specifically formatted. You really just have to look it up, and you'll notice, like, because I'm not used to it, I still have to look up a lot of the basic things because it's not muscle memory for me. I don't use SQL directly very often. Yeah, any questions about queries so far? Or queries make relative sense? All right, well, if queries make sense, we can keep going through this, where I think we just have some examples, and I'm not positive. I know Zainab updated the assignments for today, so you guys should pull most recent or whatever. But the best way to learn SQL is basically this, where someone just shows you a SQL command and the state of the database, and you tell them what it results in, because it's just understanding what the commands do. So assuming this database, if we said select star from students, this is what we get. And then if instead of select star, we set ID first name, we just get those two values, but we still get the whole students table. Now we're adding a conditional. We're saying where ID equals 2. Now we're only getting the student with ID of 2. As you can see, the where clause supports a fair number of things. So, you have what you might expect in terms of equals, not equals to. Sometimes you have access to things like between, in, or like, which those make sense sometimes when you have strings. For example, like can say matches anything that is like this string. and you could use wildcards. So you could say match anything with, match anything like, star.txt, and it'll match anything, that looks like that ends in .txt. In works if there's a list of values, between works for between values, and it'll all depend on the data type. So like, I think between is very useful if you're using like a time data type, because without having to do any extra logic, because it knows it's dealing with date time values in that, column, if you say between this and that, it's going to understand what you mean. So just some more examples. So it's sometimes odd the way you read it, but basically we're saying like, I'm looking for any student with the first name of Andre, which is usually going to be one person. Or we're looking for all enrollments where the grade is not equal to A. So that's a little weird syntax, but as you saw here, you could also simply write, not equal, or, exclamation equal, which is what you're used to for not equal. Select star from classes where credits are between 3 and 4. Select star from enrollments where grade is in A or B. Select star from classes where name is like art, what is that? Percentage symbol. I think that's the wildcard symbol in SQL. So that would mean anything that starts with art and ends with anything else. And where credits are greater than 3. So basically with your ands and your ors and these different terms, you can create any kind of conditional you want to limit what data you actually grab. Here's an example of insert into. Same with update. As you see, you could actually update, there should probably be a comma in there, but otherwise you could update more than one thing at a time. Delete. This is an example of not using the where condition for update and delete. So you'll notice that update and delete, by default, you're updating a table and you're saying what to set, or you're saying delete from a table. And then we use that where to say which element we care about. But if we didn't, if we said, update addresses, set line 1 equal this, zip code equal that, that means update every single address in that table. Alternatively, delete everything from that table. So those could be useful at times, but that's probably not always what you want. And so you should be somewhat careful about that, because part of the idea of a database is that because it's your ultimate source of truth, if you delete everything from a table, it's really gone. Unless you backed it up in some way, you just deleted everything, and it doesn't ask you, hey, are you sure you want to do that? It just does it. And as far as I'm pretty sure this is the end of this this PowerPoint. So we're good on that. And just to check here, if I look back here, is there anything we haven't seen? So we saw a little bit about this join stuff. I believe we cover it more later. Joining is kind of an advanced topic, in my opinion. But right, I guess we didn't see something like count. I wonder what Postgres calls something like count. But if I were to search for count, this is an example of, boy, I'm telling you, this search feature doesn't give you anything. I don't understand why it even worked, why it's even there. Like, it's always bringing me to this same page. Count would definitely be in here. It's an example of a built-in like function, and you do have some of those. I would love to see what the other ones are. Functions, I guess maybe is where it'll be, aggregate functions. So right, so you're going to have these functions that are built in, things like average, for example. You could see how some of this would be useful. We're just going to use count because it's the main one. But what I could do there is I could say, normally I could say select star from users and it'll give me all of the users, but I could just as well use this built-in called count, which you can make that capital or not, it doesn't actually matter, but I would make it capital because it's a built-in. And that is just going to return us the actual value 4 because we said count. But you have these other powerful ones like sum, min, max, count, average, and those are, also things that you imagine would be useful if you cared about them. And I guess when you see things like this, you should think like SQL is not too different from Excel. There's no visual component, but you have a table essentially, and you have certain built-in functions on that table. And I believe if you wanted to, there's ways of writing your own functions, but it's not built-in functionality because you can go so far with these built-in ones. So I don't know that it really makes sense, but let's say I took all of my users and I said, I don't want everything, I just want their IDs. So I would say, okay, here's all my users' IDs. But what if I wanted to say, okay, well, actually for each ID, I want the sum. So what's the sum of all the IDs? It doesn't really make sense for IDs, but you could see how, let's say I had some table that had users and then a column like number of orders. Well, I might want to say, what was the total number of orders for all the users? But either way, it works where I was able to sum all of those numbers and return a single number. And you'll notice here that it doesn't just return 13, it returns basically a column called sum with a single entry called 13. So every time you call a SQL query, it's going to return you an entire table. That table just might have one column and one row, but SQL only deals with tables. And let's see, other than that, this is just telling us some stuff about what makes modern relational database management systems good. I mean, there's a lot that could be discussed there, but I wouldn't worry too much about it. Like you could learn about PostgreSQL for your entire life and all the smart decisions it made. But the benefit of a database is that you don't really need to know how it works. It's supposed to be something of a black box where you just need to know how to talk to it in SQL. And you don't need to worry about how it accomplishes anything. So that is that basically. Where does this lead? This leads to that very lecture I just showed you. So yeah, that is everything that we need to discuss. We still have a half an hour from what I can see. It looks like I'm just gonna add I added a comma in there originally, but right, it's saying because there's some new stuff, I got to pull it. So this is just me wanting to get Zainab's new stuff. This is actually more complicated than anything I wanted to show, but we're going to do the normal way of doing a pull. So I'll do a pull and it looks like everything matched up, but there should actually be things should look slightly different now. Which I might even be able to see with git diff. Maybe there's too much to actually see. Okay. But anyways, if I go back to my file, get rid of that. If I go back to my file here, from what I understand, something in assignments changed. We can even go to GitHub if we really want to see what Zainab added. So we could say, what is it? GitHub Tango Platoon curriculum. And I don't know if you've ever seen this feature, but we can go to week 5. We can go to day 1 where we are right now. Intro to databases. And then if we click, if we click history, for example, we can see, okay, well, on March 6th, which is today, Zainab updated the SQL assignments. So I'm going to click there and it's going to show me exactly what changed. So this was added, some things were removed, some things were added. That's all we really need to know. But those are the changes. So yeah, any questions that we have about SQL stuff? I feel like we should stay in the class a bit longer and talk about this, just because there's a lot, and you almost certainly do have questions, and we didn't cover everything SQL does. So you might as well talk about it, figure out how it works.
We went over creating tables from scratch. Is there a way to load data in?
There definitely is. I'm not sure exactly when we get to it, but eventually we discussed the idea of an ORM. ORM stands for Object Relational Mapper. And that's how you interact with a database like PostgreSQL in a language like Python or JavaScript. And so I think the general way that you would, if you didn't already have that database existing, you would probably have some kind of file that represented everything you wanted in the database, like a CSV file or something. And then you would use Python and whatever ORM you use for Python to just go through that CSV file, and for every row in the CSV file, you create a new entry in your database. I'm not sure how it would be done without the ORM. There probably is a way. I see we have load sample database here. So from what I can see here, if you already have a database in PostgreSQL, there should be some kind of command that will output this tar file. Tar being a what do you call it? Like a zip file, essentially.
It's just a compression standard.
Exactly. It's a compression standard that is used in general situations. And so we have no idea what's in this database. We put it in a tar file. And so you can load from a tar file, but I think if you wanted to, what they call seed your database from some existing file, and you didn't already have it, you would just like have to create some like comma separated value file and then walk through it and add everything in there using a programming language. So I hope that's a good enough answer.
Yeah, it is. Thanks.
Yeah. And we'll get to that in time. If SQL seems annoying to use as it is right now, that's because it is. As in, even though you need to have this command line interface as a last resort, most people are not going to interact with the database this way. They're either going to do it programmatically using a language and an ORM, or they're going to have some kind of GUI, like they're going to have an app that lets them see a table and add things explicitly, because this is not a terribly nice way to interact with your database. But it is always the truth, which is nice. Okay, any other questions about what we've discussed today? Any things we want to try or?
Sure. How do you start up the database really quick from the beginning?
As in, how do you create a new table? Or
no, just how do you even get to that point before that? Like, let's say you just opened up a terminal.
Okay, cool. Yes, let me exit all of this out. Oops. So I just did Command D, and that got me totally out of anything I was in. So the first thing is it's going to matter based on your environment. So because I'm using Brew, right? I did Brew install Postgres, that put Postgres in my computer, Brew install PostgreSQL. And then that gave me access to this thing called pSQL, or I could say, we have stuff in the, if I were to go back to, where is it here? And I were to go to day 1, week 1, you'll see I have Mac set up here, and we do mention this stuff in our setup. So for install fs Mac, I say brew install PostgreSQL. That's going to install PostgreSQL. And then PostgreSQL is its own sort of thing, and brew apparently knows about it. So you could say brew services restart PostgreSQL at 14. So I'm pretty sure just as well I could say brew services stop PostgreSQL at 14. Did I get that just right? So if I say that, what happens? It stopped it. Okay, cool. And so now if I were to try and type in PSQL Postgres, what happens? So if I just try and type PSQL, it says, sorry, I don't even know, like I'm trying to connect on this server, or I'm trying to connect to this port where I know you told me PSQL is, but I see nothing there. Is it running? Well, no, it's not, which is why we need this, which I don't know why it's not called. I wonder if start works, but restart basically stops it if it's running and then starts it. So that is the common one. But if I say services start, okay, it did start it. Cool. You'll notice, I don't know if you could see it, but on my computer, I got a little pop-up, and you'll always see that pop-up to tell you, you just did, like basically you just did something the computer cares about in terms of signing into something. So PostgreSQL is running in the background now, and now I could say PSQL. But it doesn't like that because it's saying, hey, I've never heard of this database, Benjamin Cohen, right? Well, why is it saying that? It's saying that because if I were to print my current ID, is that how I do it? I, on this computer, am Benjamin Cohen. Benjamin Cohen is not the name of any database. So the way Postgres works is that we have to say PSQL Postgres. And what that actually does is it logs us in as a user called Postgres, and then access PSQL from this default user called Postgres. And now I actually have access to my tables and stuff. And that is a useful feature if you want to have multiple users with multiple different databases. But by default, we're just going to say there's only one kind of database, and it's all going to be under this name called Postgres. And then, yeah, once I type PSQL Postgres, I'm inside that thing. Those commands are going to be slightly different on Linux and on Windows. But at the end of the day, as long as you get to this screen where you say Postgres equals $, and you can type like \D, then you're good. So \D is telling me all the databases that are currently associated with this user Postgres, which is everything I ran. And that's students, users, and that third one is not one we created ourselves, but that's how it was able to have the not unique constraint for the user emails. So sometimes you'll have extra tables like that. And we'll go into all that. I don't even know what that is. Any other questions? Well, if we don't have more questions, it might be worth looking at this join idea. Like I mentioned, join was this idea here where we were able to take two tables and join them based on some foreign key in one table and the primary key in another. And so this on statement was able to join those two tables, and it resulted in not a permanent table, but this temporary table that we could then return things from. But it did that using this idea called a join. And let's look at how this works. So we're saying we have, I might as well put these in. I'm going to create a table called A. So over here, I have this new table called A. I could see that by going like this, and I see like, yep, there actually is a table called basket A. And that basket A table has an A, which is its primary key. It's ID essentially, and then it has a fruit A, which is a string up to length 100, which is not null. And now let's do the same thing for B. So notice we don't actually technically have an ID column here, but we're using these columns A and B to represent the key. And now I'm just going to add some stuff into basket A to begin with, so we actually have some data to work with. And similarly, I'll do that with basket B. And the whole point of that is so that now I could say something like select star I could say select star from basket A. And that's everything that was in basket A. And similarly, select star from basket B. That was everything that's in basket B. Cool. So coming back here, I have my sorry. Just trying to make my zoom stuff a little smaller so it doesn't take up as much space. So I have that A and B, right? And then this is what they look like. Here's my basket A, here's my basket, or here's my table basket A, here's my table basket B. And now the first thing is I might want to do a join. And so in this case, we're talking about an inner join. So what is an inner join? We look at this diagram here, and it's like a Venn diagram. It says we want to join everything in A with everything in B, but importantly, only when they perfectly overlap. So what does that mean? Well, if I take this join statement here, I'm saying I want to see everything in A. I want to see A, fruit A, B, and fruit B. I think I could just replace that with select star. And I want to grab it from basket A, but I want to do an inner join to basket B. And how do we line them up? Oh, I see. Okay. They're saying, how do we want to line them up? Well, we only want to line them up when fruit A and fruit B have the exact same value. Okay, well, we saw that sometimes fruit A and sometimes fruit B do have the same value, and there's no reason a join has to be done on a key, although it usually is done on a key. So what I might have here is something like select star from, and we always start with one table. So we say basket A, and then how do we combine basket A with basket B? Well, we say inner join. In this case, inner join, which means just when they're in common. Inner join basket B. And how do I want to join it? With this on statement. And this on is going to say, in this case, I'm saying fruit A and fruit B because those are only in one table from each, but I could be explicit and say basket A, which is the name of the table, dot fruit A is equal to basket B dot fruit B. The only reason it lets us leave it off is because those are unique to one table versus the other. And then what this returned me was everything in A and everything in B where fruit A and fruit B lined up exactly. So that is an inner join. But what are the alternatives? Well, a left join is similar to an inner join, but it doesn't just include the overlap. It also includes anything that's on the left, i.e. anything that's in the first table you told it about. So in this case, we're saying select everything from basket A, left join with basket B when fruit A equals fruit B. So it looks identical to that first join we did, but instead of a inner join, we're doing a left join. And left join means if it's in basket A, I want to see it in this final table we're creating, but only join it to basket B when fruit A equals fruit B. So let's see what that looks like. I'm going to create another select from basket A, not an inner join anymore, but a left join. And I want my left join to only happen, or my left join is with basket B, but it should only do the join when basket A's fruit A and basket B's fruit B are the same. So what do we get? Cool. So what we got was everything that's in basket A, which is 1, 2, 3, 4, apple, orange, banana, cucumber. So 1, 2, 3, 4, apple, orange, banana, cucumber. And then everything that's in B got tied to it as long as it satisfied that condition. And so similarly, we could do the opposite, where we could have a right join, in which I'm saying, again, get everything from A and B and join them according to this, whether fruit A and fruit B are the same. But importantly, don't show me everything from the left side, i.e. basket A, only show it if it overlaps, but for the right side, basket B, show everything. So if I do this now, it's going to show me everything from B, 1, 2, 3, 4, and orange, apple, watermelon, pear. And then fruit A has been added, or the table of A has been added on only where that condition matched. And then we have one final thing, which is, so this was an example of a left join. It looks like that. And then a right, or I guess you can get more specific. You can have a left outer join, which means I actually don't care when they're the same. I only care about the things that are different. So basically all the variations of a Venn diagram are going to show up in these joins. Here we have our right join. And this would be a right outer join, I guess, because it, I guess by default is generally an outer join, but we could have a right inner join. We're saying we don't actually, or sorry, this is the right outer join. We're saying we don't care about what's in there. And then finally, we have the full outer join, which is everything, including all nulls. So if I go back here, I think just writing full join would be enough. And exactly right. I have everything that's in A and everything that's in B. And then when they line up, they line up. But when they don't line up, you just have nulls where they don't line up. And the ones you will see most commonly are inner join and full join. Sometimes you'll see left join. Sometimes you'll see right join. That outer stuff is even less common. But like, yeah, basically any way you could have a Venn diagram is possible. And you might say, what's the situation where you care about this? You care about everything. You care about combining everything in the left table and everything in the right table, but leaving out the parts where they're common. You only care about when they are different. Maybe that would come up at some point, but it's not common. The common ones, so here we have, all the options. The common ones would be inner join, just where they're the same. Then I guess after that, the most common would be left and right, where you say where they're the same, but I specifically care about keeping all of the stuff from the first column or all the stuff from the second column. And then finally, the one in which you say, I just want everything from both columns. And to the degree they don't match up, just put nulls in its place. So I hope that makes sense. The reason I covered joins just now is because from what I heard from Zainab, we don't necessarily cover it that much, at least at this point. So this is just for you to see it, but you probably won't need it at all for today's assignment. Yeah, that's it. I'm not sure what else there is to talk about, but as you can see, there's a lot in the docs here. So it's worth digging into if you want to talk about it. Just like that where conditional, you can have an order by that sorts it, ascending or descending. So if I went back here, let me look at, right, order by comes from. So if I went back here, I might have select everything from basket A, which would be that, but maybe I want to say select everything from basket A, and then I'm going to add at the end of it an order by. So 2 words, yeah. And what I want to order it by, well, actually I want to order it by A, which is like my primary key, but importantly, I want to say not ascending, but rather descending. So I believe that's DESC. And now it should give me back everything that's in basket A, but ordered according to A descending, which is what it does. So you can see how that would be useful. Like there's another thing in here called limit. And limit is another thing we can add in addition to order by. So I could say something like this, where I say limit 1. And because of how I wrote it, it's going to get me only it's going to get me the highest just the highest ID row of basket A, which it does. And the cool thing about SQL is that it's smart enough that if you wrote something like that, it did not first grab everything and then order it and then grab just the top one. It was able to take that whole statement and say, oh, they just want the one with the highest ID. So let me just go find that one and return it. And so it doesn't waste a lot of time or effort. Basically, the benefit of SQL is you're almost guaranteed that it's doing it as efficiently as it can, because it's such a structured query language that it knows all the possible ways you can combine things, and it does them in the right order so that it doesn't waste time or memory unnecessarily. Cool. We got 5 minutes. We still have more talking about if we want to do that. As you can see, there's just so many of these little keywords. So I could say offset or something. So maybe I'm saying I only want the, this is weird. I'm saying I want everything from basket A. I want to order it by A, but make it descending. And then I want to limit it to 2, but I want to do an offset of 2. So I actually want to skip the first 2. So this is going to get everything from basket A, order it according to 4, 3, 2, 1 by this ID of A. Then it's going to say I only want 2. That would normally return me 4 and 3, but because I said offset of 2, it's going to ignore the first 2 and then give me the next 2. And that's what happens. So this is really powerful when it comes to, like, let's say you have a website and that website, it has some kind of pagination, right? So the first page, you look at the first 100 elements, the next page, you look at the next 200 elements. This is how you would do that. The first time you're looking at the page, you would say, get me everything from whatever that, database is. And let's say we take out the order by, because we're fine with our current order, but we'll say limit it to 100 because we're on the first page, right? And I don't have to have an offset, and that'll give me the first 100 for that database. But imagine this is a very large database. Well, I actually want to say, when I hit the next page, I still want 100 for that page, but I don't want the first 100 because I just saw those. So instead I say offset 100, and that would give me the next 100, which there's nothing in this table for that. But you could kind of see how combining these things, you can get the specific data you want no matter what. Yeah, so there's just so many special things here. I've never even heard of select distinct, but I guess that means only when there's not a match. So like you wouldn't select 2 things with the same email. If you said select distinct email, it would only grab the ones that had a unique value there. There's just lots and lots of keywords because essentially it's its own language. SQL is a full-on language just for writing queries. And so anything that could have to do with a query is here. Never heard of cube. Okay. But yeah, that's it. I think we know enough that we can do the assignment now. In 2 minutes, we're going to be done with this, and then we're going to come back and talk about the assignment, I suppose, or just do the assignment when we come back. But if we want to look at it for a second, let's look at it right here. Here's where we had this, and then these are our current assignments. Here's something to read about. I might as well click all of them. So we have some reading we want you to do because we know we haven't really covered everything. And then there's this thing SQL Zoo. Okay. So besides for the reading, we have this one assignment, and we walk through how to do it, but you'll notice here, based on that question someone was asking before, like what if you want to, you know, add lots and lots of elements to your database? Well, if you've already done it, SQL can export something to you with a .SQL, and that's a seed for your database, so someone can easily create a new database with that same data. And this is what that seed looks like. It's just actual statements one after the other. Do this, do this, do this, do this, and it creates your database. Yep. And then what is this? SQL Zoo. These are just, I guess, tutorials where do you actually have to write it at some point? I hope you do. Yeah. Okay. So it's just an interactive SQL thing where the database is somewhere there and you can type something in and something will happen and you'll find out if you were right or wrong. So the big skill today is just learning how to use SQL and use that, you know, use a website with documentation on SQL to build queries that will get you the data you want. Okay, we're at 11 and it sounds like no one else has questions. We're open for, I'll be open for questions for, you know, another few minutes, but we are at time. So let's just, I'll stop sharing and I'll stop recording.